Okay, Sharon and Rick, this is the clock after I've done all the work on a test wall that I have here in the shop. I like to show people a video of it actually working, and so this is it going. I just put it up here, just finished all the work. We're going to go closer in and show you how a clock actually works. I'm trying to look through a camera and climb on a stair at the same time. So all the gears, starting with the lower gear where the spring is, the spring turns that bottom gear, which you can see there, and then it turns the next gear in line, the next gear in line. That's these pivots right here through this escapement, which is a little difficult to see through here. But this is how a clock runs. The pendulum does not run the clock runs the pendulum. And that seesaw action we're watching right there is the pendulum being pushed back and forth. So that seesaw piece is called a verge. Where those pointed teeth are hitting the verge are called pallets. And you can see that they're adjustable on this clock. You can see screws there, or bolts. They were way out of adjustment. And if you look to your left, straight in the center there, to the left, right over here, you'll see some scribbles on there. That's somebody's repair identification number. I'm not sure what that is. I see that all the time, scribbling on clocks. But somebody had misadjusted these. The clock was badly worn, and there were many other problems actually. In a simple clock, it was quite complicated. But this action is what's pushing the pendulum back and forth. That tooth wheel with the pointed teeth is the escape wheel, and once you start the pendulum in motion, it allows the tooth to escape from one side and hit the pallet faces on the opposite side, which pushes the pendulum back in the opposite direction, and then that tooth escapes as the pendulum pulls that verge back down towards gravity, and a tooth comes crashing into the other side. And that action keeps pushing this pendulum back and forth, all powered by the spring through a train of gears through this escapement. This whole area up here at the top is called the escapement. That copper wire we see coming out of there goes through this piece, which the pendulum is hanging on. You can see the top of the pendulum hanging right there. And that little piece through that slot is what's pushing this pendulum back and forth. All done mechanically. So I like to show people this. The clock had bushings put in the holes, pivots all polished. They were quite badly grooved and pitted and worn. The main wheel here with the spring attached to it had problems, which I can show you in pictures. And the spring itself was in good shape, though. After being sitting for so long in one position, it still had plenty of power. Well, we're going to check that actually, but it looks like it has plenty of power. It should run for a week. We're going to check that running period on this test period right now. So anyway, so this is it up in the wall running, and it's running very nicely. Pendulum has very good motion. The tick is nice and loud, and that's one of the ways that we judge how well it, what kind of condition it's actually in, is how well it's ticking, and with what kind of vigor and snap the pendulum changes direction as the escapement works. And as you can see right here, it's actually running very vigorously. It's got great motion. It's very quick, and the pendulum is going back and forth with a lot of vigor. So we'll cut this off now and show you this when we get there.